You're about to do a test. Okay. Oh, good, Elizabeth. I'm so glad that you said that. It is my wish that you do very well tonight. Just take your time and answer what you know, okay? Okay. All right. So tonight we're going to look at these bonds, and y'all, I've got so much planned for y'all today. So make sure, again, as you guys are coming in, tap the screen. Oh, yes, yes, no problem. Make sure you all tap the screen because that's going to help send this out to everyone so that they'll know that we are now live here, okay? So make sure that you guys are tapping that screen left and right. Tap, tap, tap. Okay, tap, tap, tap. Now, I do have some practice questions that I'm going to give you all that deals with VSEPR. And this is pretty much what you guys are seeing here, okay, on the screen. Now, on YouTube, those YouTube streets, I am going to do something for you all too, because I know several of you all are over there on YouTube. So I'm going to actually be switching the screens off back and forth. So here's what we got. You need a periodic table, all right? The periodic table is going to help you also because with the periodic table, you're going to have to look at certain things that I'm going to disclose to you about the way it works, okay? So let's go ahead and get into this lesson now. First off, okay, give me 1 second, y'all. Hold on. Let me make sure all my bells and whistles are there. Okay, yes, this is what I wanted to kind of go through right here. All right, so right here on the board, you'll notice that I have a copy of the periodic table, right? But the thing is, you have to keep in mind that with this periodic table, the periodic table is very helpful for you for a number of reasons. The reason why you want to know how to work the periodic table out is because it's going to help you when it comes to keeping things into perspective, okay? So when we look at the chart, all right, I'm going to actually color code this chart for you, all right? And when I color code this chart, I want you all to walk with me through each of these problems. So I'm going to erase this so that you guys can see it from the very beginning of how I showed it to the students earlier, all right? So this is your bare periodic table, just a blank slate, all right? A blank slate. Now, what you have to do is know a couple of things, okay? When it comes to your periodic table, all right? Know a couple of things. One thing you need to know, of course, are the number of valence electrons that these elements will provide. Once you know that, that's going to also be a key to what you have to know, all right? So when you talk about these valence electrons and these numbers, you want to know what each of those group numbers represent, all right? Now, when you look at the group number will tell you what that is, all right? So when we look at group one, matter of fact, I'm going to zoom in just a tad bit, okay? Making sure that you all can see this. And I'm going to try to make sure that I'm not blocking what you all need to see. Okay, so I'm looking over here, all right, to make sure we're good. Now I'm going to make me a little bit smaller, okay? There we go. All right, so now, here we go. In group one of your elements, okay, when it comes to writing this out, group one elements has one valence electron. Group two has two valence electrons. We're going to skip groups 3 through 12, and I'm going to tell you why in a minute. Groups 13 through 18, you drop the one off. So for group 13, you get 3 valence electrons. Group 14, you have 4. Group 15, you have 5. Group 16, you have 6. Group 17, you have 7, and group 18, you have 8 valence electrons. Now, here is what I'm going to have you all look at this part next. I'm going to now look at the charges, and these charges are going to play a role in our upcoming lesson. Group one, those elements have a positive 1 charge. Group 2, those elements have a positive 2 charge. Group 13 has a positive 3 charge. Now, group 14 is unique. It has a positive 4 charge, but it also has a negative 4 as well, and that is because carbon specifically has the capabilities of receiving extra valence electrons. So 90% of what you guys do in chemistry deals with the positive 4 charge, but the reason why we have a negative charge is because it can receive extra electrons. So let me show you what I mean by that. When you have a positive ion, okay, those are called cations or cations, depending on where you're from, tomato, tomato. Also, they have the ability to give away, okay, donate. All right. So think about it. If you are positively charged, you are always giving away your energy. Okay. You're always giving away and giving to other people. However, when you are negatively charged, okay, such as group 17, it has a negative 3 charge. Okay. And let me make this a little bit smaller here. All right. Group 15 has a negative 3 charge. Group 16 has a negative 2 charge. Group 17 has negative 1. And of course, is neutral or 0 for group 18. Why am I giving you all this information? Well, because when it comes to valence electrons and writing out what's called the molecular shape, all of this is going to play a role in how we put these shapes together. So when they are negative ions, we refer to those as anions, and that means they have the ability to receive, okay? Look, let me spell that right. Receive. That means you're going to add to them, all right? So over here, we're going to add when we see a negative charge, but we're going to subtract when we see a positive charge, okay? We're going to add when the number is negative and subtract when the number is positive. You're going to see what I mean in a second, all right? You're going to see what I mean by that. Now, here's something else I want you guys to understand. When it comes to this information here, you cannot overthink how this stuff is done, okay? I don't want you guys to overthink it. Please don't overthink it, all right? And here's why. Because you don't have to, okay? Now, when the charges are positive, for instance, okay, what you have to do, you have to only draw one valence electron around that given element or whatever the elements are. So let me give you an example. If I told you to draw out the molecular geometry for, let's say, just the first element, let's say hydrogen, right? Hydrogen is in group 1. Here's hydrogen right here. It's in group 1. So guess what? We're only going to put one little dot beside the hydrogen atom right there, just that one dot, okay? If I ask you about, let's say, magnesium, which is right next door, it's in group 2, which has 2 valence electrons. Magnesium is going to come in with 2 of those dots, and you can put them side by side or on one side opposite of each other. Now, when you get to, like, let's say the negative groups, okay? Let's look at group 15. Let's look at nitrogen, for instance, right here. I'm going to color code it so you all can see that, okay? When we look at nitrogen, right? Nitrogen has 5 valence electrons, okay? Because it has 5 valence electrons, what does that mean? That means you're going to have to do what? You're going to draw 5 dots around that element, okay? 5 dots around that element. So in this case right here, you're going to see how the color-coded numbers are going to make this make sense, all right? So here we go. We've got nitrogen, and nitrogen is in group 15, and we're going to draw 5 dots around it. 1, 2, 3, 4, and 5. That's the 5 dots that this particular element is going to contribute whenever we draw the compound out with nitrogen attached. Now, you see that number above it, right? That green number, -3, right? Guess what that means? This tells me that elements in that group has the ability to gain or acquire 3 more valence electrons to keep it whole. What's popping, Austin? How you doing? So therefore, because I know that, the rule in chemistry is the magic number of 8. 8 is what we call the octet rule. Completing the octet rule tells me that the element, as long as it gets to 8, it is complete. So these elements require, from groups 14 through 18, they require 8 valence electrons. And because they require 8 valence electrons, that means we're going to have to make sure that that element has a total of 8. So when I look at nitrogen, it's in group 15. It provided 5 valence electrons. It needs 3 more. That's just one element. Let's look at another one, all right? Let's take a look at fluorine, all right, which is the most electronegative element of them all. Fluorine, right here in group 17, is going to contribute 7 valence electrons. So here we go. 1, 2, 3, 4, 5, 6, 7. Now, fluorine says, all right, I'm good, except I need 1 more to make me feel good. So that's why fluorine has a -1 charge, okay? So you see, when we start putting this all together, you're going to realize where the red numbers tells you how many valence electrons it's coming in with. The blue or green numbers tells you how many it's going to give away or receive. Give away, or receive, okay? Let's go ahead and start putting these together now as formulas and compounds. The first step you need to do anytime you're doing molecular geometry shapes is you have to determine how many total valence electrons you have for that compound, okay? Oh, thank you, Kyla. I think, is it Kyla or Kaylee? You asked a very good question. How do we know the ones in the middle? Very good question. I got you. Elements from groups, and I'm gonna highlight it in red for you, okay? Matter of fact, let me do a different color. Let me put it in this neon blue color right here. Basically, any elements from groups 14 through 17 must go in the middle, okay? The elements from groups 14 through 17 must go in the middle. And that's so that they can do what's called the octet rule, complete the octet rule. 8, they must be surrounding themselves by 8 valence electrons. So think about it. The person who is the center of attention, they have to be showered with attention. So you're going to basically give the person that's like the head of the group, you're going to give them the most, okay? Yeah, so the more electronegative, they go in the middle. That is correct. The farther right you go, the more chances are this element going in the middle. Most of your metals will not go in the middle. So like you will never get potassium in the middle. You won't get like anything from groups 1 and 2 through really 13. Those won't go in the middle, with the exception of boron. Now, speaking of which, there are these things here on this line here, okay? I'm going to highlight it in pink. And these are your, what we call your metalloids, because they go both ways, okay? So on this staircase right here, these are your metalloids, okay? If they touch the staircase, they're metalloids. But we'll get back to them when we cross that bridge. Now, what I'm going to do for you all is show you how simple this can be when it comes to practicing these problems, okay? So I'm going to actually give you some examples. I may or may not use the periodic table, like, because, you know, just to keep going up and down with it. However, if I do, good. If I don't, I'll give you what you need to know for those elements, okay? I'll give you what you need to know for those. So let's go ahead and do an example right here. Let me go ahead and pull some from my other page so that you can see how all of this works. Okay. All right, so I'm gonna start you guys off though for starters, okay? And these are some of the questions I actually give my students. But I'm gonna actually start you guys off here. We're gonna start off with the very basic one. Let's look at HCl, okay? We're gonna start off with HCl. Oh, you love doing these. You said you learned this during your freshman year in physical science. Fantastic. I'm glad you love it. Because I know when I was in school, I did not like this because it didn't make sense to me. Now it does. And you know why this is something that you all need to know? This helps us break cases in forensics, particularly, thank you, Mina. This helps our students understand how certain people get caught up with the with drugs. And here's why. Do you all know that there's one, okay, as an example, if you're looking at me, because you can see my screen, it's mirroring back to you what you see. In other words, it's not backwards, right? But if you were to go and if I hold up my left hand, okay, and put it in the mirror, holding up my left hand, yes, hey, you said, Jasmine said you are in forensics. Well, honey, let me tell you how this is going to help you. There are drugs that they call mirroring each other. They're like isomers, where if I'm holding up my left hand in the mirror, it looks like it's my right hand. So this is how some of these drugs are. Like there's this thing called D-methamphetamines, and then there's L-methamphetamines. Well, the D one versus the L one can be proven to cause you to get in trouble in the law enforcement, because some people use certain drugs from the pharmaceutical to make meth. However, you also can get meth from Vicks Vapor Rub, but one of them is legal, the other one is not. So this is where the Vesper and the shapes of those drugs come into play. So I'll dive more and do a story time on that later, but that's how. So there's that forensic chemistry connection. Now, when you look at hydrogen, okay, Kelsey, you're gonna make 100 on this part, honey. Look, just walk with me, you're gonna see. So you've got one hydrogen right here. You've got one chlorine. You're going to separate them out and you're going to multiply them times their respective numbers of valence electrons. So you've got one valence electron for hydrogen because it's in group 1. You've got 7 valence electrons for chlorine because it's in group 17. When I add those two numbers together, 1 plus 7 gives me 8 valence electrons. Now, you know what we're going to do now with this? Well, Chris, I'm glad you came by. This is going to, I got an easy way to help you on this part of your test. Now, what you're going to do is take the first element that you see, which is hydrogen. Well, before I even get to hydrogen, let's get to chlorine. I'm going to tell you why. When you draw chlorine out right here, chlorine is going to come in with 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Now, chlorine is sitting there crying like a big baby, saying, I mean, I'm grateful for the 7 that I'm contributing, but I need one more to make me feel good about myself. So hydrogen says, all right, I'll come to your little party and I'll give you one of my valence electrons. So now when hydrogen comes up on the scene and drops one of its valence electrons, chlorine now is happy, saying, yo, I'm glad you showed up because now I've got 8 valence electrons around me. Now I am complete. Chlorine came in with 7 because it's in group 17. Oh, thank you, Chris, for the goat gift. Thank you, thank you, thank you. Appreciate you. Thank you. Hey, Ashanti, congratulations for being a chemistry major. Listen, I got some P-Chem notes, right? But it's been over 30 years since I looked at them bad boys. You got this. P-Chem is nothing but math. Okay? It is basically a repeat of stuff that you've already seen. It just looks foreign because of all those different symbols and all the formulas that you've got to go through. Yes. But congratulations, Ashanti. Congratulations. I love my chemistry majors. So now what you're going to do is redraw this out, but instead of having those two little dots there, you're going to do what? Replace them with a dash. And there you have it. Yeah, those partial derivatives used to whoop me too, girl. But listen, you're going to get through this. You are going to get through this. Oh, yes, you're welcome, Maya 5. You're welcome. You're welcome. So that's how you do these problems. Now, of course, y'all, we're going to do more, right? Because, I just can't let y'all just do only one and say that's a one and done. No, we're going to actually do some more, okay? So let me give you all another compound. And again, oh, you're welcome. I'm so glad y'all are all coming through here. Yes, Ashanti, look, if you need a pep talk, come holler at me. I can pep talk you up, okay? Okay. And if you need to go to the tutor center, honey, you better go in there and stay in there as much as you can, okay? Stay in there as much as you can. And go to your professor's office hours also. Yes. All right, y'all. Let's look at water. H2O. H2O. Now, what we're going to do is separate these compounds out. We've got 2 hydrogens and only 1 oxygen. We're going to multiply them both by their respective numbers of valence electrons. Hydrogen has 1 valence electron because it's in group 1, but there are 2 of them. So 2 times 1 gives you the 2. And then oxygen, it's in group 16, so we drop the 1 off. That's where the 6 comes from. So 1 times 6 gives you 6. We're going to add those together, and we get a total of 8 valence electrons, okay? 8 valence electrons. Austin, I feel you. You are absolutely right. Chemistry, we do have a love-hate relationship for it. Yes, I totally agree. Now, so far, before I go any further, is everybody getting what we're putting down? If you are getting this, put either a purple heart in the comment box or put the chemical symbol in the comment box. If you are getting this, if you're picking up what I'm giving you, put a heart, purple heart in there. Oh, thank you, Camilla. Appreciate you. All right, look at all them purple hearts just lighting up. Okay, excellent. Excellent. Now, we got to draw this out, right? Let's go ahead and draw. So here comes oxygen. The loudest element between the hydrogen and oxygen is oxygen. Oxygen's like, yeah, I'm bringing 6 things to this party. And you can put whatever things you want to say, okay? So here's oxygen. Said, all right, I'm bringing 6 whatever. Whatever you want to say, there they are. But I ain't happy. I'm not satisfied. Why is oxygen sitting there griping and complaining? They bought 6. How many more do they need? Let's roll back the periodic table. Here's oxygen right here. I'm going to highlight it for you so you all can see it. It's right here in yellow. How many more valence electrons does oxygen need? If it came in with 6, what's the number above oxygen? If it's coming in with 6, thank you, Kelsey. Very good. It needs 2 more. That's where that -2 comes from, y'all. So whenever you all look at the charges above the numbers in red, that's telling you how many more it needs or how many more it needs to let go. How many more I need to receive or let go, okay? So in this case, oxygen needs 2 more valence electrons. And where is it going to get those 2 more from? From each of the hydrogens. So here comes the first hydrogen. They roll up to the party like, all right, I heard you needed something. Oxygen said, yeah, give it up. Give me that 1 that you got. So here's that hydrogen saying, all right, here's your 1. And then here comes the second hydrogen pulling up, saying, all right, I got mine also for you as well. And now oxygen can go sit down somewhere and have several seats, okay? Because now oxygen has 8. Remember, 8 in chemistry is the octet rule of completion. Yep, that's right, Pam, for universe. That's right. It is complete. So now, if you look at the total number of little dots that you see here, this will indicate this total here that we first initially calculated. And voila, this is done. Now I'm going to take those little dots away and I'm going to replace them as dashes. Those dashes represent bonds, okay? They represent bonds. All right. Y'all good so far? How y'all feeling? Let's keep it moving. Oh, good question, Kaylee or Kylie. Good question. Will compounds always equal 8? Not necessarily. Not necessarily. Matter of fact, here are some examples here. Now, this is a great segue. Okay, so let's look at NH3 right here. All right, so I'm going to make these a little bit bigger so that you guys can see this, right? Because we're going to also get into those that have polyatomic ions. Like, what do you do with those? So let me go ahead and make this a little bit larger. Okay, so we can kind of work this out together. And I'm going to tell you how there's an easy fix for a lot of these, okay? So let's see here. Okay. So take a look at this one right here. Number 1. Trying to make sure y'all can see it before I actually do it. Okay, right there. There we go. Number 1, it says, what is the total number of valence electrons in NH3? All right, let's see if you all can get this today. Okay, so you've got N, you've got H, but you got 3 of them. So you've got N and H, 1 nitrogen, but 3 hydrogens. Nitrogen is in group 15. Drop that 1. So you get 5 valence electrons for nitrogen. 1 times 5 gives you 5 valence electrons. Hydrogen, there are 3 of them, but hydrogen is in group 1, so that's where the 1 valence electron comes from. So therefore, 3 times 1 gives you 3. So in this case, we end up with 8 valence electrons. So yes, letter B is the answer. Letter B is the answer. Good job, Abe and Austin. Good job. Now, let's take a look at number 2. Someone had asked, is it always, are compounds going to always equal 8? And the answer is no, because check out number 2 right here. So in number 2, it says, what is the total number of valence electrons in carbon dioxide? All right, well, let's go ahead and draw this out or write this out. You've got 1 carbon times 4 valence electrons because it's in group 14, but we dropped that 1. And then we've got 2 oxygens times 6 valence electrons, all right, because oxygen is in group 16. So 2 times 6 is 12. And then you add those together and you get 16 valence electrons. 16 valence electrons. So far, easy peasy, right? Okay. Let's take a look then at number 3. Suppose you have a polyatomic ion, right? What are you supposed to do if you have a polyatomic ion? All right, so guess what? Remember what I told you, if you have a negative charge, a negative ion, you're going to add. But if you have a positive ion, you're going to subtract. Okay, keep that in mind. Keep that in mind. So with this particular compound here, okay, we've got S and oxygen, sulfur and oxygen. We've got 1 sulfur ion times 6 valence electrons. So 1 times 6 gives you 6. Then we've got 4 oxygen atoms, but guess what? Oxygen also is in group 16. So we therefore have 6 valence electrons. So 4 times 6 gives you 24. So 6 plus 24 gives us 30 valence electrons. But guess what, y'all? That ain't it. That ain't the answer. 30 valence electrons is not the answer, because when we have a negative charge, we're going to do what? We're going to add 2 valence electrons. It's all good, hey, Matt, it's all good. So when we add 30 plus 2 together, we get 32 valence electrons. And guess what? There are going to always be answers on there that will get students caught up if you don't look at everything, if you don't consider everything. All right. Now, what I want you all to do is the next one, okay? You've got NO3. This is number 4 now. NO3. And y'all, make sure y'all run them hearts up, because the more hearts we got, it's helping me get this sent out to everybody, okay? Oh, thank you, Kelsey. I'm glad you stayed too. Aiden, this is chemistry for college students and high school students. That's how easy I make it. Okay. All right, number 4. Number 4. We've got NO3. So we've got nitrogen and oxygen. 1 nitrogen, 3 oxygens. Nitrogen is in group 15, so you're going to multiply that times 5. 1 times 5 gives you 5 valence electrons. You've got your oxygen, but that's in group 16. Drop that 1 and you get 6 valence electrons. 3 times 6 is 18. Now, if we add 5 plus 18, we get 23 valence electrons. Now, here is the deal. Anytime you have an odd number of valence electrons, that tells you you've got a free radical. Free radicals are not good when it comes to chemistry, okay? Free radicals are not good in chemistry. So in this case right here, when we have 23 valence electrons, we got to think, wait a minute, the math is not mathing. So you've got to remember that negative charge right there means to add 1 to your total. So you get 24 valence electrons. So letter A is the answer. Yes, I do. Bizam, I like your name. Bizam asks, do I have a website? Yes, I do. Upstairs in the profile, it'll take you straight there. I have a course that you can, not a course, but a membership if you want access to all the worksheets and the edited versions of the lives. Now, let's take a look at PCl5, okay? We're going to do one more like this, PCl5. PCl5. Right here, you're welcome. you've got phosphorus and chlorine, okay? Phosphorus and chlorine. Okay, you said you're doing this in chemistry right now. It's so confusing. Okay, did you just join? Did you just join the live? Because if you did, then continue to hang tight and hopefully your questions will be answered. You've got 1 phosphorus and 5 chlorines. So phosphorus is in group. Let's go ahead and pull the periodic table back because sometimes you all still need to see that part, okay? So phosphorus right here as a refresher. Here's phosphorus right here. It's in group 15. You see that I just highlighted it for you. So therefore, it's going to contribute 5 valence electrons, okay? So right here, you've got 1 times 5. That's going to give you 5. And then you've got your chlorines. Chlorine is in group 17. Drop that 1 and you get 7. So 5 times 7 is 35. So therefore, 5 plus 35 gives you 40 valence electrons. So letter B is the answer. Okay, now here's what we're going to do now with this. We're going to practice drawing these pictures out again because what I only showed you so far was just some of the basic ones, right? You know, we just showed you some of the basic pictures. But now we're going to use the pictures to determine the shape. We're going to use the pictures to determine the shape. So earlier, when we did HCl, okay, when we did HCl, this is what it looked like earlier, right here. On your chart, or not your chart, but on this, well, it is a chart. On this chart, you look at it and it's going to tell you a couple of things. You got to ask yourself 2 questions. How many bonds do you see? And then how many non-bonding pairs of electrons do you see? Okay. If you ask yourself those 2 questions, this will help you to understand the shape. Now, just FYI, when you have just 2 elements off gate, it's going to be a linear shape. So this is what VSEPR is, okay? Yes, yep. See, we're right there on the same wavelength, Maya. Yep. This is VSEPR right here. So I just pulled up the chart so you all can see this. So you would follow what I'm putting out there so you all will know exactly what I'm referencing, okay? So we had, and it's always based on the middle element. So y'all, you know how it is when you say, oh, they got a big gut. You know, when you look at somebody and you be judging, when we be judging the shapes of these elements. So when you look at a person's midsection, you're thinking, wow, what's going on there? Well, sometimes a lot of people have the midsection because they're having to release so many cortisol hormones that causes the stress to just lay right there in the middle. Some of the ladies have big guts. Some of the fellas got big guts. The guts tells you your health status to a certain extent. I'm working on mine, okay? However, when it comes to chemistry, we're judging the middle element to know what the shape is for the middle element. So remember how I said if you have just 2 elements, it's linear? But I got to prove that to you. So here it is. Just 1 bond and no bonds paired to the middle element. Well, there really is no middle element. It was just hydrogen and chlorine. It is a linear shape, okay? So I'm going to be referencing this chart to help you guys understand where all this lies, okay? So let's go back over here to another example. You're welcome, Austin. You have a wonderful evening, and I may see you tomorrow morning, okay? Have a good one. Take a look at water. Okay, we did that one earlier, okay? Remember how we said water looked like this, okay? Matter of fact, let me make sure Did we do that? Yeah, we did that one. This is the one right here that we drew in green and blue. You see that? So I'm going to go down here to the clean version. Okay, so you all can see this one right here. Now, my question for you is, how many bonds are attached to the element in the middle? How many bonds are attached? There's 1, 2. All right. There are 2 bonds attached to oxygen. Next question. Next question. How many non-bonding pairs of electrons do you see? How many non-bonding pairs of electrons do you see? How many pairs? Still 2, right? Okay. Just like if I say how many pair of feet do you have? You have a pair of feet, okay? And if you're beside your partner, then together y'all have 2 pair of feet, all right? So you don't say I have 4 dots, 4 total. Yeah, you do have 4 total dots, but you don't have 4 non-bonding pairs, okay? Just FYI, in case you get twisted with the verbiage, okay? Yes, I'm glad I'm here for you. D with the pink heart. Hey, Cole, how are you? So now what you're going to do, you're going to go up here, and because we put 2 and 2, right? You see that? 2 and 2. Let's scroll back up here to the top and look at our chart. You see right here where it says 2 bonds to the central atom and 2 lone pair or non-bonding pairs of electrons. This shape is bent. This shape is bent. Therefore, that's what we call the shape. Okay? So if you ever look at water, and if I take water in one pipette and rubbing alcohol in the other pipette and let them drop, guess what? Water will form like a little bond, okay? Or like a little bubble. But every time I drop rubbing alcohol, it's evaporating just quickly. It's because of the molecular shape, okay? It is a molecular shape. So now, let's go to another example, okay? Let's go to another one. That way you all will know how to do this when I actually give you all another multiple choice example, okay? Let's take a look at NH3. NH3. We did that one earlier, I believe, but let me make sure. Oh, we just did the math for that, but we did not draw the structure out. So let's draw the structure out for NH3. We already know it has 8 valence electrons. So you've got nitrogen. Again, we already did the math, but I'm just going to go ahead and write the math out real quick one more time so you all can see this. All right, so now there's 8 valence electrons, okay? 8 valence electrons. So now what you're going to do, right there, I'm going to put nitrogen in the middle because nitrogen is the most electronegative element in this case. So here's nitrogen with 1, 2, 3, 4, and 5, okay? Now, you're going to pull in your hydrogen because y'all know nitrogen is complaining. Nitrogen is like, wham. I only have 5, but I need 3 to make me feel happy. So now what we're going to do is pull in hydrogen. Here's the first hydrogen saying, here, take that. Okay? Like Puffy. Here comes the second hydrogen saying, all right, here's yours. And then here's your third hydrogen. And there's the third dot. Now, as you can see right here, okay, from your picture, let me scroll this up a little bit. And D Pinkheart, I'm going to show you the periodic table in a second, okay? So now, if we take a look at the picture right here, all you have to do is replace those dots right there with the dash, okay? Now, how many bonds? I'm going to ask y'all this. How many bonds are popping off the middle element? There's 1, 2, and 3. Do you see those 3 bonds right there? 3 bonds. How many non-bonding pairs of electrons do you see? How many pairs do you see? Thank you, Sheila. That's right. Thank you. 1. You see 1. So if you have 3 bonds and 1 non-bonding, let's go up here to our chart. Right here, you're going to find 3 bonds, 1 lone pair of electrons, and the shape is trigonal pyramidal right there. Now, what you guys have to do, you have to remember, there's a 1 and a 3 on here also, but not in that order. Not in that order. So you want to make sure that the first part that you see here where it says atoms bonded, you're going to go by the first one that we looked at. So don't make sure that you guys are aware of how to use this chart. So yes, this shape is trigonal pyramidal. Yes, trigonal pyramidal. Maya, you said now the lone pair, I thought it was only 1 before we added hydrogen. Well, remember, you're going to put the whole picture together first. Then you can determine how many lone pairs you have after everything has been put into place. Okay? So, we're going to do another one to make sure you guys are good to go, right? Because I want to make sure that you all are not going to be confused when it comes to these problems. Now, let me give you this one right here. Oh, the periodic table. I'm sorry, honey. I'm sorry. What did you want to know about the periodic table? So I'm gonna pull it down. Yeah. What did you want to see? Like, what did you want to know about it? Oh, you want to see the valence electrons? Okay. All right. Okay, so let me tell you how I wrote this out so that everybody will know how to work it, okay? The numbers that I wrote in red, those indicate the numbers of valence electrons. So anything that you see in red, those are the valence electrons. The charges above it are either in blue or green. This tells you how many extra electrons it needs to satisfy it. So particularly those that are in that blue box, those tell you that you need to acquire more. No, Kylie, I'm so glad you asked that question. Do valence electrons not apply to the 3 through 12 column? They don't per se. They have their own set of issues. They have their own set of issues. Okay, so now I'm going to give you all some more practice problems to make sure that you guys can do it. And before I give you some more, let's get it up to 10,000, y'all, 10,000 hearts, okay? Yes, so let's see if we can get up to 10,000 hearts before we get to the other problems. 10,000. Yes. Matter of fact, I'm copying some of those right now as we speak. Yes. Yeah, it's like we're right there, honey. We're right there. Yes, yes, yes. All right. Okay, so let me go ahead and erase this right here. Hey, Ra. Yes, I do Chem 2. That's the second level of general chemistry. Yes. Yes, yes, yes. What are you guys working on right now? Okay, so right here, you've got a few more examples, okay? And so I know that you wanted to know if I was going to get to the the polyatomic ones. Here's your first one. Since you asked, here you go. You got it. So let me make this a little bit bigger so you can see it, okay? All right. So we're going to look at the first one, H3O plus, the hydronium ion. All right, let's take a look at that one. Okay. What are y'all doing in General Chem 2? Okay, so right here, this is one of those polyatomic ones, okay? So you've got the hydronium ion. First up, we've got to do what? We've got to do the math for this. We've got H3O plus. So we've got 3 hydrogens times 1 valence electron. That gives us 3 valence electrons. And then for oxygen, you've got just 1 oxygen times 6 valence electrons. And now 1 times 6 gives you 6. And when you add those together, you get 9. But you know the math ain't mathing if you've got an odd number. 9 is odd. You cannot forget about this positive sign. In chemistry, when it's positive, we subtract. So we subtract 1 from that, and we get 8 valence electrons. Also, you guys are doing electronic configuration. We did that last week. So I actually have videos on my YouTube channel based on electronic configuration. Yes. Okay, so now what you've got here, when we put this picture together, I'm going to now show you all how to do a polyatomic ion with a positive charge, okay? So what you have, you're going to put oxygen in the middle with 6, 2, 4, and 6. Okay, now hydrogen is coming in with 1. Here comes a second hydrogen with 1. Here comes a third hydrogen. But we don't have to add 1 because there is a positive charge. So we don't have to worry about the extra one because we deducted it away. Okay? Oh, good. Perfectly imperfect. Good, 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 good. Excellent. There's a lot to that CLEP exam, and you can do it. You can do it. So what you're going to do now, we're just going to replace those little dots, excuse me, there, and we're going to replace them with a dash, okay? So let's go ahead and erase those dots. Whoops. And we're going to replace them with dashes. But I actually need to pull this down because it's up too high. So I'm going to pull it down. I'm just going to basically redraw it, y'all, okay? And this was your picture right here. And I'm going to put it in brackets. And I'm going to put the positive charge on the outside. The reason why we're doing it like this is because whenever you have a polyatomic ion, you've got to put the compound in brackets. And on the outside, you're going to put the charge that either was added or taken away. Now, let's take a look at the shape. How many bonds are popping off of oxygen? How many bonds? Thank you, Games. A valence electron is negative. So no, not a valence electron is negative. If the charge is positive that's on the polyatomic ion, you've got to deduct it. If it's negative, you've got to add it. Okay, there's a difference. There is a difference. How many bonds are popping off of oxygen? Okay, yeah, thank you, Maya. 1, 2, 3. All right, next question. How many non-bonding pairs of electrons do you all see? Thank you, Sheila, for the cone, ice cream cone. Thank you. Correct, guys. 1. So 3 bonds attached, 1 non-bonding. Let's see what shape this is. 3 bonds attached, 1 non-bonding tells us trigonal pyramidal. Okay? Trigonal pyramidal. And there you have it. So right here, 3 and 1. Yep, that's it right there. Trigonal pyramidal. No, I only do general chem 1 and 2. I don't do organic, inorganic, P-chem, analytical. No, I don't do those. I only do general chemistry 1 and 2. So our answer here is letter B, trigonal pyramidal. Hey, Z, why can't I do OChem? Because, honey, we had a love-hate relationship when I was in college. So it wasn't my cup of tea. I actually understood P-chem a lot better than I did organic. All right. Let's do number 3, okay? You're starting to need a little help with biochem. Okay. What are y'all doing in biochem? So now you've got CH4. All right, let's break this apart. You've got 1 carbon, 4 hydrogens. Oh, okay. Good, Games. Good. You've got 1 carbon times 4 valence electrons. So that gives you 4. Remember what I said? Group 14 has carbon in it. The charge normally for carbon is +4, but there are several cases where you would have a -4. This is that time right here. Because if it's positively charged, that means it would give away its charges. But in this case, it's negative. So therefore, it's going to need to pick up other valence electrons to make carbon whole. So now you've got 4 hydrogens times 1 valence electron. So 1 times 4 gives us 4. So when we add those together, we get 8. Okay, so let's see what shape this is. We've got 1 carbon coming in with 1, 2, 3, and 4. You've got your hydrogen coming in with 1. You've got the second hydrogen coming in with 1. You've got your third hydrogen coming in with 1. And your fourth hydrogen coming in with 1. Everything is accounted for. All right, Niels, good. So you erase those little dots and you replace them with dashes and you get the shape. How many bonds are popping off of carbon? Oh, yeah, okay. Yeah, I wouldn't be able to help you on that. Yeah, sorry. Yes, there are 4 bonds coming off of carbon. Are there any non-bondings by any chance? Any non-bonding pairs? Y'all see any non-bonding pairs of electrons? No. Thank you, Michaela. That's right. No. You're welcome, M. You are welcome. So 4, 0. Let's go up here to our chart to see what shape this is. 4, 0 is what shape? Yep, we have satisfied the octet rule. Yes, that is correct. So therefore, what shape is this? Tetrahedral. Very good. Not, yeah, that's it. Tetrahedral, right here at the very bottom. All right, guys, y'all got this. Y'all got this. Okay. All right. So, I mean, y'all, it can't get any harder. Now, I did not do any double bonds earlier. But listen, if y'all want me to do a double bond, was there a step where it included half? That's probably talking about formal charges and stuff like that. When you talk about half, yeah. Hey, Dr. Aaliyah. Yes, that deals with the uh formal charge. If you have to find a formal charge, because then you have to use this formula right here. Oh, thank you. Thank you, perfectly imperfect. I'm glad. Look, we had perfect timing, okay? Perfect timing. Oh, it's on the other screen. Hold on. Yes, what do you want to know about the periodic table? What else do you need to know? Let me see. I actually had this other chart that dealt with the question that you were asking about the formal charge. Yeah, because formal charge is equal to the number of valence electrons minus 1/2 times the number of bonding electrons plus your non-bonding electrons. So that was one of the formulas that you could actually use also if I asked you to find formal charges. So Maya, if you want to know about formal charges, that's what that is. You know what? Yes, I can. Because I don't have a video on that. Let me write this down so I won't forget, okay? So I don't forget. Formal charges. Matter of fact, write that on my next video or on my latest video. Just go and write that in, and then that way I'll be able to do a video response to you. Okay. But I'm gonna also put it on my YouTube channel. But if you go to my last video, while this information is still fresh, I will do a video for you on formal charges. Yeah. All right. Oh, and Hazel Basil, I got you on the hybrid orbitals. Yeah, I'll do that as well. So right there on my last video too, hybrid orbitals, because I that takes a lot to go into detail for. So I will do that for you as well. Yes, yes. Hey, Issa, what's going on? Yeah, we were just doing the molecular geometry tonight. That's what we were focusing on tonight. And that's on the TEAS exam too. Now, I hate to break it to y'all, but for those of you out that are taking the TEAS exam, there are 9 chemistry questions. You may see this on your test. Like, out of all the stuff that we have to know, or that I have to teach, that you have to know rather, there are only 9 chemistry questions. Go figure. Yes, I do. Oh, yes, thank you. It's up in my profile. You click it, it'll take you straight there. Make sure you subscribe. Do I have any tips to help you all remember the geometry? Look, Issa, look, just pretend like I'm beside you. Pretend like I'm whispering the answers in your ear, okay? Pretend like I'm giving you the guidance that you need for your test. Okay? All right, Games. Thank you. You're welcome. See, you remember that. That's right. See, you remember that, Issa. That's right. Let me see what's this. Alex, you want to know tips for memorizing this chart? Well, let me tell you. It's kind of simple. I mean, I don't want well, I mean, what's simple to me may not be simple to you. Let's start there. But if you can remember pretty much, you say for AP chemistry, sometimes the shapes will tell you what they are. Like just looking at the shapes and getting the visuals, like this one right here, this green and purple one. See how there are four things around it? Like that's tetrahedral. Linear is when you have just the elements that are like locked in on the same line. Bent is when you have two elements coming off the one in the middle, and then there are two non-bondings that are attached. I'm gonna write this down. I'm gonna see if I can perhaps make a separate video on how to memorize that, but the chart should be given, and I put that in quote, it should be. Not that it is, but it should be. Maya, let's do that one next. Carbon dioxide, let's do that one next. Yes, it is, but let's do that one now. Because now that's going to go into the double bonds, okay? No, but what we're doing now, I'm actually streaming now on YouTube based on what we're doing tonight. Yes, this is actually streaming right now on YouTube. We're doing stoichiometry in about 2 weeks. Yes, stoichiometry is coming up. But I do have a playlist on stoichiometry right here on TT. Okay. I do have a playlist on stoichiometry. Now, we did do the math for carbon dioxide, which is 16 valence electrons. So I won't do the math again, but we're going to actually draw this out. Yes, I do have email. Yes. Up in the profile. Now, oh, let me see. Where was that question? I thought I. Okay, maybe I didn't. Hold on. Okay, yeah, I'm gonna do carbon dioxide. Oh yes, we are. Yes, yes. This is also an AP. Yes, we're gonna do the carbon dioxide one. Because that's a good one, number one, but it also deals with double bonds. If y'all want doubles, I need y'all to run it up to 15,000 hearts. And look, that ain't much to do. We got 77 people in here. Okay. So if y'all can do me a favor and get me up to at least 15,000 hearts, then you got me on the carbon dioxide. Okay. Yes. And I'll do carbon dioxide. If your grade is an 85 in what? Regular chemistry? Honors? Oh, yeah, that's good. That's good. Is that chemistry teacher the only teacher that teaches like at your school? Like, will you have them again for AP chemistry? Okay. So here, yeah, we're almost at the 15. But what I'm going to do while you all are running the bag up of the hearts, I'm going to just put the math here. We've got one carbon, two oxygens. Carbon is in group 14, so therefore we get 4 valence electrons. Oxygen is in group 16, so we get 6 valence electrons. So 2, because there are 2 oxygens, times 6 gives us 12 valence electrons with a total of 16. Okay, I'm gonna pause there. And when we get those 15,000, we're gonna show y'all how to get this double bond. Yes, out games. If you could put that question on my last video also about dipole. I got a whole notebook full of video responses that I am working on. So put that one on there too, so I can actually do a video response for you as well. Oh, good. Okay. Okay, good. Issa, good. Good, good, good. Excellent. Excellent, excellent. Okay. Hey, Ava, you're a chemistry professor too, or a chemistry teacher? So good. Okay. Hey. Hey, chemistry colleague, how you doing? As far as topics to help you on the CLEP exam, I recommend that you go to the CLEP website and see if there are practice questions that you can take. I would if go to the library. Wait, when are you taking the CLEP? Before I continue my statement, when are you taking the CLEP exam? August. Okay. Okay, you have until August. Okay. Here's what I recommend that you do. You should go to the library. Okay, go to the library and get, if you can, an AP chemistry book and use that, because there are practice test questions in the AP chemistry book that you could benefit from to help you for your CLEP exam. So I would get the AP chemistry book and practice on, of course, some of the more challenging concepts in chemistry. Well, of course, you got your protons, electrons, neutrons, trends of the periodic table, things like that. But you need to focus on stoichiometry, balancing chemical equations, and then all the multiple steps that you have to do in order to solve some of those types of problems. So I would recommend that you start there first. Go to your public library and get a copy of an AP chemistry book. Start there first. Start there first. And by the way, DM me, because I may have some other things I can tell you too. Okay. Yeah, DM me too, so I can give you some further tips. Yeah. Okay, guys, we're gonna finish this one out. Okay, we got our 15,000 hearts. So let's conclude with this one right here. Okay. So you've got oxygen in the middle, but oh, not in the middle. Sorry. I'm glad I said that to kind of now redo this part. You got two elements, right? Those two elements are competing to say who gonna go in the middle, who got next. Well, you only got one carbon to two oxygens, so therefore you're gonna have to put carbon in the middle. So let me go ahead and pull this down some more. Oh, that's a dope major. Okay, that is a dope major. Forensic chemistry. You can't go wrong with that. What do you want to do with it? You've got 4 valence electrons around your carbon. Now we're going to pull in our oxygens. Here we go. That's 1, 2, 3, 4, 5, 6. Here comes your second oxygen. 1, 2, 3, 4, 5, 6. Well, that one don't look right. Let me scoot it down because that was a little high up. There we go. And 6. There we go. Now, if you take a look at all of these right here, you see how I'm going to highlight them in purple. You see how these are left alone by themselves? When they are left alone by themselves, you can never have one solo electron, valence electron. You've got to pair it up. So where we're going to pair them up? In the middle. The middle element must have 8. And any element that is a part of group 14, 15, 16, or 17. Oxygen also has to have 8, but hold tight, because what we're going to do now is we're going to pull, first off, we're going to pull these 2 that's on carbon, those 2 blues, we're going to pull those together first. So watch this. Don't blink because you're going to miss it. I'm going to erase the one that's on the bottom, and I'm going to bring it up here to the top. Right there. See that? They're together. These 2 oxygens here that are solo, I'm going to bring to the middle. So don't blink because I'm going to deal with the right oxygen. So I'm going to take this extra dot that was on the bottom left and on the bottom right, and I'm going to pull it right here between the carbon and the oxygen. Okay, okay. Thank you. If you can do that, thank you. All right. So now, take a look. You've got a double bond right there between carbon and oxygen, right? Let's count. You've got 2, 4, 6, 8 around the oxygen on the right. You've got 2, 4, 6, 8 around the carbon in the middle. But you've got 2, 4, 6 only around the oxygen on the left. Therefore, we're out of compliance. So what you need to do is bring the 2 that are above carbon right here, bring it to the left. I'm going to drop it right here. I'm going to erase those 2. And ChatGPT can be wrong, Adrian, Rios, or Rios. ChatGPT does make mistakes, makes mathematical mistakes. I don't have a problem with students using ChatGPT, but you got to know how to use it to pick out the mistakes. Keep that in mind. Keep that in mind. You can be copying the wrong numbers and not realize why you got something wrong. So now, if you count everything up right here, I'm just going to replace everything with the dashes. You've got 2, 4, 6, 8 around the left carbon, 2, 4, 6, 8 around the left oxygen, 2, 4, 6, 8 around the carbon in the middle, and 2, 4, 6, 8 around the oxygen on the right. And now you are done. So when we actually go in and see how many elements are popping off of carbon that's in the middle, there are 2. You don't count double bonds as double. There are only 2. So there are 2 bonds coming off of carbon, this oxygen and this oxygen. There are 0 non-bonding pairs of electrons. So 2 and 0, let's go back up to our chart to see what shape we've got. Right here, 2, 0 tells us this is a linear shape. Thank you, Lindsay. Appreciate you. All right. And now we are done, guys. My voice is dry. I've been on here for an hour and a half. Thank you, Lindsay. And my throat is dry. Y'all know if you drink on TT, it makes it think that you're doing something you ain't got no business doing. Okay. So I'm going to pause for a second and catch my throat chakra. Okay. I need to protect my throat chakra. So I'm going to get some water right now. Please do perfectly imperfect. Please do. You're welcome, Soph. I appreciate you. You're welcome. And yes, guys, listen, I will be back on tomorrow morning. On Fridays, I normally play games. The games are like review. It's like test questions, but on Kahoot style. So I'm going to be asking you all some review questions on everything that we've learned all this week. We've dealt with electronic configuration. Oh, let me turn my face back on. We've dealt with electronic configuration. Well, that was last week, but we also dealt with writing chemical formulas. So on Kahoot's test tomorrow, we're going to be doing a test on chemical formulas and then also molecular geometry. Oh, yes, it is fun. So y'all got to make sure you bring your periodic tables tomorrow and you'll have plenty of time to answer the questions. Oh, good. Ruski, you got an 85 on your midterm. That's good. Excellent. I haven't tried that yet. What is that? Blue-Ket or Block-It? What is that? I like playing games so that my students don't have to stress while they're learning. Okay. Oh, okay. Okay, that's good. Nayeli, why did you get a 19 out of 34? What happened? Excuse me. Okay, guys. So yes, I'm going to end it right here. I thank y'all for getting me up to at least 19,000 hearts. I appreciate y'all. Oh no, Cookie, you got 15 out of 33. Oh yes, tomorrow. Yeah, I'm on the East Coast time too. I will be here tomorrow at 10 a.m. Eastern Standard Time. Oh, I think weren't you here yesterday night, Nayeli? Because I remember we talked about this before. Your teachers do take off points when you don't put your units there. That's for sure. Unfortunately. Yes, but don't give up though. Don't give up. You know, yeah, you didn't realize it. Yeah. But you can't give up. You know, that's just one quiz or one test. And like I said before, we change our mindset just because you got not a good score the first time. That's okay. That's just one thing. That's just one quiz, one test. Just hit the reset button and do it again. Okay. Arlena said, before you pair the electrons, how do you know how to put the valence electrons around each element? Well, that's because each of them tells you, each element tells you how many that they need to come into the party with. So, okay. So when we were talking about, let me find one real quick so that way you will know what I'm talking about. Okay. So I'll give you one as an example. I'm just give you a basic one. Okay. Um, NaCl, sodium chloride. That's pretty basic, right? Sodium is right here. Sodium is in group 1. And because sodium is in group 1, it's going to only contribute one little dot. Chlorine, on the other hand, chlorine is right over here. It's the one I'm highlighting in purple, right there. Chlorine is over here. So therefore, it's going to contribute 7 valence electrons.